Here's a question for you. Is this disk speeding up or is it slowing down? Don't answer yet, just watch it. It really looks like it's speeding up. So what's going on? When you first launch the disk, the wobble gets faster, the pitch gets higher. It almost feels like it's winding itself up for one last burst of energy. But here's the strange part. Actually, it's slowing down the entire time. So what's going on? When you first launch the disk, almost all of its energy is in the spinning. Nothing surprising there. But as it gradually loses energy, something interesting starts to happen. It begins to lean over, and now it isn't spinning anymore. It's spinning and it's rolling. But also, it's wobbling around the point where it touches the surface. That wobble has a proper name. It's called precession. You've probably seen it before on a spinning top, but here's the clever bit. As the disc leans over, the circle it's traveling around gets smaller and smaller. Imagine running around the outside of a football pitch, and now imagine running around your kitchen table. If I ask you to complete both laps in the same amount of time, which one would you have to run around faster? Exactly. The smaller the circle, the faster you have to move around it. That's exactly what's happening here. The disc isn't gaining energy, isn't breaking the laws of physics. It's simply traveling around a smaller path, which makes the wobble happen faster and faster. Your brain sees faster movement and assumes it's accelerating. It's just geometry playing tricks on you. Then something else happens. That incredible ringing sound. As the disc wobbles faster, the tiny point where it touches the mirror races around at an astonishing speed. That creates vibrations in both the disc and the surface beneath it. Those vibrations become sound. As the vibrations get faster, the pitch gets higher. Then suddenly, everything stops. Now, there's a word you might come across. You spend enough time around these things. Spalling is a mashup of the words spinning and rolling. Because by this point, that's exactly what the disc is doing. It's no longer just spinning. It's spinning, rolling, and precessing all at once. As it races towards that final moment. The wobble gets faster, pitch climbs higher, and then everything ends in what we like to call the singularity. Spalling isn't a formal scientific term, but it's a nickname you'll often come across among people who are fascinated by these disks. Now, here's what I find amazing. For years, physicists couldn't agree on exactly what made the disk stop. Was it air resistance? Was it friction? Or was it something else entirely? It turned out to be a combination of effects, with friction, the contact point, playing a much bigger role than people first expected. I love that, because it means something that looks so simple was still teaching physicists new things. But while scientists were busy asking, why does this work? Someone else started asking a completely different question. What if we rebuilt it using 40 years of modern engineering? And that's where this story takes a very unexpected turn.